Data that is normally distributed can be used as a probability function. In this case, the standard deviation becomes particularly valuable. You can use it to determine the proportion of values that fall within a specified number of standard deviations from the mean. For example, in our normal distribution below, the mean is the center of the curve. One standard deviation to the right of the mean is mu plus sigma, and one standard deviation to the left of the mean is mu minus sigma. Remember, mu is the mean and sigma is the standard deviation. Two standard deviations to the right of the mean is mu plus 2 sigma. Two standard deviations to the left of the mean is mu minus 2 sigma, and so on. Understanding this, we can learn the 68, 95, 99.7 rule. This is a statistical rule and is also known as the empirical rule for normal distribution. This rule states that on every normal distribution curve, 68% of the data lies within one standard deviation, 95% of the data lies within two standard deviations, and 99.7% of the data lies within 3 standard deviations. The image below gives us a clear picture of this rule. In one standard deviation, we have 68% of the data. In 2 standard deviations, we have 95% of the data. And in 3 standard deviations, we have 99.7% of the data. Now let's summarize our past few lessons on what we've learned about the normal distribution. We know that a set of data that is normally distributed has a symmetric bell shape when graphed. Generally, measurements of living things such as mass, height, and lifespan have this type of distribution. The mean, mode, and median of a normal distribution is equal. And we've just learned the empirical rule, which states 68% of the data lies within one standard deviation, 95% of the data lies within 2 standard deviations, and 99.7% of the data lies within 3 standard deviations.